Hello, everyone. This is Sultan Al-Awar. I'm an experienced data scientist and certified AWS ML practitioner. I'm recording this video as a set of other videos to be followed in order to cascade my knowledge and skills that I have gained while studying for the AWS certification that I have earned in the beginning of this year. So to start in giving a overview description of the certification as it's advertised by AWS, the certification is intended for individuals who have been working in the field of data science and have more than 1 year of experience developing, architecting, or running machine learning / deep learning workloads in the AWS cloud. Additionally, candidates should have the hands-on experience and knowledge in how these models work, how it can be developed, how it can be run, and they should have the ability to apply model training, fine-tuning, deployment, and to recognize the best practices when it comes to ML ops. So the plan is to have a separate video which explains the content of each of the 4 main blocks or sections of the examination, which are as follows. There are 4 main blocks of the AWS ML certification, which is mainly data engineering, that weighs 20%, EDA or exploratory data analysis, which weighs 24%, modeling, which is the biggest and most important section. It weighs 36%, and the 4th section is the ML implementation and operation, which weighs 20%. So as I said earlier, the plan is to have one dedicated video which explains the main topics within each section, and at the end of each section we'll have sample questions that we will answer, and which like application of the explanation of the main topics, and these sample questions are identical exam questions that you might encounter while sitting for the exam. So if we start with the first section, which is section number 1, data engineering, it mainly focuses on data collection, storage, preprocessing, and transformation for machine learning. So it's the first primary step when working on an ML project, is like to think where this data can be collected, how it can be collected, where is it stored, and how to store the output as well, how to process it and transform it to make it ready for ML training. The main topics that we'll aim to tackle in this section are as follows. We're going to talk about S3, Kinesis, networking, VPC endpoint. We're going to talk about the Glue ETL, data pipelines, Elastic MapReduce, AWS Step Functions. And as I said, we're going to end it with some sample questions. We're going to tackle these questions. We're going to provide some strategies, how to read the questions, what to look after, and how to select the best correct answer from the given choices. So the first topic is Amazon S3. I'm sure that most of the people who have experience in the AWS cloud, they know what does S3 stand for, and it is a storage tool which allows people to store files known as objects in buckets which known as directories. So S3 can be used as a data lake or centralized architecture for data storage. So whenever you notice any question, something related to data lake or centralized architecture, then you have to think of S3 as a potential solution for that. Within S3, you have the lifecycle configuration, which allows you to move objects between different storage classes. And the most known or the most used storage classes, it could be S3 standard, which is mainly used for highly frequent access data, such as big data analytics and content distribution. If we have data which is needed to be infrequently accessed, then we can go to the second class, which is S3 standard infrequent access, and which is mainly used for backups and recoveries. The third S3 storage class that we're going to talk about is Amazon Glacier Deep Archive, which is used for long-term storage and it's less costly. The fourth S3 storage class is S3 Intelligent Tiering, which simply it allows users to move objects automatically between tiers based on the data usage. So this is a figure which simply depicts or summarize the available S3 storage classes. And as you see, the line goes from most frequent access data to less frequent access data. And for S3 standard storage class, we're mainly talking about frequent data. If we have less frequently accessed data, we can go for S3 standard infrequent access. And if we are just like saving data for long-term usage with less access, then we can think of archive or S3 Glacier Deep Archive storage class. So the two most important factors that someone should consider before choosing which S3 storage class they should go after is first how frequent the data should be accessed. So frequency of accessing the data. And the second point is it's the cost. How much cost I should incur with data. So if I'm looking for less costly solution, then I should go for Deep Archive. If I don't care about cost, then I can go for the S3 standard storage class. The second topic that we're going to talk about is S3 encryption. So there are two methods of encrypting objects within S3. The first one is what we call SSE S3, which mainly encrypts S3 objects using keys handled and managed by AWS, and this is the default one. And the second encryption method is called SSE KMS, or what's known as key management service, and it gives customers an ability to generate these KMS and with additional security in order to manage encryption. So if we are after like more secure solution or like more with more security, then we should go for SSE KMS. If we are okay for AWS to handle and manage encryption, then we should go with the default one, which is SSE S3. The next topic that we're going to talk about is Kinesis. So Kinesis is known as AWS streaming service, which is used for application logs, matrix, IoT or Internet of Things, click streams, and real-time big data. So whenever the question is asking you for a solution which entails about big data, application logs, click streams, then we should think of Kinesis. Within Kinesis, we have four main pillars that every candidate should know, is which can be summarized as follows: Kinesis streams, which is mainly used to ingest and process large amounts of streaming data in real time with low latency. We have Kinesis Analytics, which allows users to perform real-time analytics on streams using SQL. We have Kinesis Firehose, which simply loads streams into different destinations, such as S3, Redshift, Splunk, or Elasticsearch. Kinesis Video Streams is meant for streaming video in real time and to create ML applications with other AWS services such as AWS SageMaker or AWS Recognition Video. So the key thing is to know is like Kinesis Streams does the processing of data in real time. Kinesis Firehose, it helps us to load the data into other destinations in near real time, not real time. So if you want to talk more about each of these four pillars, with Kinesis Streams, it's useful to know that we have producers and consumers. Producers, we can think of it as like the data sources or the applications that send data to Kinesis for ingestion. It could be security cameras, smartphone cameras, or audio feeds. whereas consumers are the applications that retrieve and process the data stored in Kinesis streams, such as AWS SageMaker, Amazon Recognition Video, etc. It's good to know that streams are divided in order charts or partitions. And one important feature of Kinesis streams, it's the immutability. So whenever data is inserted in Kinesis, it cannot be deleted. Kinesis Firehose, we can think of Kinesis Firehose as a fully managed streaming service which sends data to other destinations. As we said earlier, Kinesis Firehose helps us to send data to other destinations, and these destinations it could be S3, Redshift, Elasticsearch, Splunk, or simply HTTP endpoints. One important capability of Kinesis Firehose, it's serverless data transformation. So whenever a question depicts something about data transformation with Lambda, then we can think of Kinesis Firehose, which entails this capability. As I said earlier, Kinesis Firehose, it helps to stream data near real time, whereas Kinesis streams, it helps streaming data in real time. Within Kinesis Firehose, we also have the capability to do automatic scaling, depending on the volume of data. And there is no need for data storage in Kinesis Firehose. So just Kinesis Firehose, it helps you to stream your data, okay, without the data storage. And we can use its built-in method to transform the data to Parquet and load it to S3. So there is no need for data storage. So whenever the question is asking for a solution which doesn't need data storage, but it requires data transformation, then we can think of Kinesis Firehose. Next, Kinesis Data Analytics. So as I said, Kinesis Data Analytics helps us to do data aggregations and to transform statistics and insights from data using SQL. But within Kinesis Data Analytics, we can also utilize machine learning. So there are two models which are currently available within Kinesis Analytics, and it helps us to perform machine learning. The first model is called random cut forest. And random cut forest, we can think of it as like anomaly detection algorithm, which help us to identify outliers or anomalies within a data set. The second algorithm is hotspots. And it's simply clustering algorithm, which helps us to locate and return information about relatively dense regions in our data. So these models, it could be used in different business cases, such as fraud detection, network monitoring, and cybersecurity. The next topic that we're going to tackle is networking, or VPC endpoint gateway. So VPC is what's known as virtual private cloud. And when we combine VPC with endpoint gateway, we can think of it as a networking feature that allows users to privately connect their VPC to AWS services, such as AWS SageMaker, without the need to go through the public internet or internet gateway or VPN or net device. So in a nutshell, we can think of VPC endpoint gateway as like it helps us to establish a private connection between our VPC and the AWS service without needing to send traffic over the public internet. So just like private connection between the VPC and the AWS service. And this is established or like achieved through using the VPC endpoint gateway networking feature. The next topic that we're going to cover is Glue ETL. Glue ETL in AWS, it helps us to run code using programming languages such as Spark, Scala, or Python. Glue ETL is serverless, so you don't need to worry about configuring or managing the resources. Glue ETL will do this for you. Within Glue ETL, you can have data catalog, which helps you to make the data available to Athena or Redshift Spectrum. Glue ETL, it can do the following jobs. It can transform, preprocess, clean, and enrich the data that you have. Within Glue ETL, you can have a Glue scheduler, which like helps you to schedule jobs at a certain time or a certain day. And then within Glue ETL, also you have Glue triggers, which helps you to automate job runs based on events, such as pushing a Parquet file to S3, which will trigger a transformation job on the data and then save the data for a database. So in a nutshell, Glue ETL offers you 3 tasks. It helps you to build the data catalog. It helps you to do data transformation and processing, and it supports you in scheduling and running jobs based on certain requirements. The next topic is about data pipeline. So data pipeline, we can think of it as orchestration service that runs on EC2 instances. However, it offers more control over the environment and compute resources. So you can manage, or you can manage the resources that you want within your data pipeline. It's commonly used in cases of when you want to do ETL unstructured data, and when you want to move data to cloud, or when you want to do Amazon DynamoDB backup and recovery. So if we think, so data pipeline, it does ETL, but it does ETL on unstructured data, and it gives you more control over the environment. However, Glue ETL, it's like a serverless. It's serverless, and it can manage resources for you. This is the main difference between data pipeline and Glue ETL. So when you want something which is serverless, you need to go for Glue ETL. But when you want something which gives you more control over the environment and compute resources, then you have to choose data pipeline. The next topic that we're going to talk about is Amazon EMR, or Elastic MapReduce. So Amazon EMR, it helps you to employ Amazon EC2 instance to analyze big data across a network of virtual servers. Whenever you see, or whenever you have like data of petabyte scale, and you need to do pre-processing for this data, then you have to choose Elastic MapReduce, which helps you to do data processing, perform analytics, or use machine learning on a huge amount of big data. It's also good to know that Amazon EMR, it uses Amazon S3 to hold data sets for analysis, like at this data storage, and for processing output. The last topic that we're gonna talk about on AWS data engineering is the AWS Step Functions, and we can think of AWS Step Functions as low-code visual workflow service that it eliminates the need to manually orchestrate application components and to manually define how they should work together. So if you want like an automated pipeline, which helps you to orchestrate how certain application would work, then you can use AWS Step Functions. It's used for building distributed applications. It's used to automate IT and business processes, and it's also used to build data and machine learning pipelines using AWS services. Other services that I would advise for you to know more about and to read their usage on AWS website is AWS Batch, which is known as a fully managed batch computing service that plans, schedules, and runs ML workloads across a full range of AWS compute offerings. The second one is AWS Migration Service, or DMS, and it's a managed migration replication service that helps you move your database and analytics workloads to AWS quickly. We also have Amazon SNS, or Simple Notification Service, and it simply sends notifications in 2 ways. There are 2 types. You have SNS A2A, which allows you to send messages between systems, and SNS A2P, which helps you send messages to customers. Other services that also you need to worry about is definitely AWS Lambda, which is known as a serverless compute service, and it helps you to run code without configuring any infrastructure. AWS Lambda can be triggered by events coming such as from API gateway, SNS topics, or S3 bucket changes. It's also good to know about EFS, or Elastic File System, and which is used for or built for petabyte scale data. It has an automatic scaling where it automatically grows and shrinks as you add and remove files with no need for management or provisioning. It can be shared by multiple instances as well. FSX cluster, it's a fully managed shared storage built on a high-performance file system. It can be used to launch and run cost-effective, large-scale machine learning and high-performance computing jobs. Other topic that you need to know about is also AWS Redshift, which is simply a cloud-based data warehousing service. It's used for columnar data storage, and it's optimized for SQL OLAP or online analytical processing workloads. And within AWS Redshift, you have something what we call Redshift Spectrum, and which allows us to run queries directly against data stored in S3 without the need to load the data into Redshift tables. On the other hand, we have AWS RDS, or Relational Database Service, which is a managed database service for row-based storage. So AWS Redshift for columnar data storage, whereas RDS is for row-based storage. And RDS is optimized for what's called OLAP, or online transaction processing workloads. We have different available relational database management services, such as Amazon Aurora, PostgreSQL, or MySQL. Okay, so this covers the explanation of the main topics which you might encounter while studying for the data engineering section for the AWS ML certification. Of course, this gives you like an overview, but definitely you should go and dig deeper on each of the topics that we talked about, and to make sure that you are grasping all their different use cases, their components, when to use it, and why to use it. And now we're gonna tackle some of the sample exam questions, which you might encounter in your upcoming examination. So the first thing that we need to know is that we have to read the question, and then we have to look into keywords that will help us to figure out an answer without looking into the answer choices. So if we read this question, it's telling us what networking component you should use to ensure that AWS services only access your data in Amazon S3 using AWS private link without going through the public internet. So we should think first of all for keywords here. So definitely they are asking about something about networking component, and they're asking us to think of a solution which helps us to connect our VPC to the AWS service without going through the public internet. So public internet is like without going is a keyword, public internet is a keyword, and network components is another keyword. So of course we did touch base on that in the explanation. And then when it comes to networking, we should think of VPC endpoints. And if you look of the choices, security groups, I think it's not relevant. VPC endpoints, we did talk about that, and it's the best solution in order to use, and it's the solution which is being implemented by AWS in order to allow users to connect their VPC to the AWS services without going to the public internet. So it's definitely solution part B, which is the correct answer, VPC endpoints. Question 2, they're asking us which of the following options would allow you to ingest, transform, and store data in Parquet form, streaming data from sensors. So they're asking about streaming data from sensors, which we should think about Kinesis because it's streaming data. But within Kinesis, we have Kinesis Streams, Kinesis Firehose, Kinesis Data Analytics, or Kinesis Video Streams. And because they're asking us to ingest, transform, and store in Parquet form, so we have to think of Kinesis Firehose, because Kinesis Firehose has its built-in method, which allows you to transform data and like put it in another destination, such as S3, Splunk, or HTTP endpoints. So from the available choices, of course, Kinesis Data Analytics, it doesn't allow you to store, like to transform. It just allows you to do some like aggregations or calculations, or like use the ML algorithms to get data insights from the data. Kinesis Streams helps you to stream the data in real time, but Kinesis Firehose helps you to ingest, transform, and store the data and put it into another destination. So definitely it's option number C is the correct answer for this question. Question number 3, they are asking us, you have data stored in S3 in the Parquet form, and you want to analyze and visualize the data. How can you achieve that? So definitely we are talking about something which around S3, data saved in S3, and we want to analyze and visualize the data. So the options that are giving us: AWS Glue, Athena, and QuickSight, Data Pipeline and QuickSight, Lambda Function, Athena, and QuickSight, AWS Step Functions, and QuickSight. For your knowledge, we didn't talk about QuickSight, but QuickSight is simply a visualization tool in AWS, like Tableau or Power BI. So this is like, it's called QuickSight on AWS. So because we have S3 and we want to analyze and visualize data, so we can think of AWS Glue, which helped us to do ETL in the data, Athena to query the data, and QuickSight to visualize the data. Pipeline, it can be used as orchestration service, like for huge unstructured data, which is not needed here. The question, it doesn't entail that. Lambda function, it can be used, but here they're asking us to to analyze and visualize the data from S3 directly. So AWS Glue would be the best answer, because it helps us to use the data which is stored in S3, build the data catalog, and then use Athena to query the data, and QuickSight to visualize it. So it's definitely option A is the most correct answer in this context. Question 4, they are telling us which AWS function helps us to convert workflow into a state machine diagram, so it becomes easy to debug. We also did talk about that as like AWS Step Functions, which is a low-code visual solutions that is used to build distributed systems or to automate IT processes. And so from the available choices, we have AWS Glue, AWS Step Functions, AWS Data Pipeline, and EMR. Data Pipeline and EMR are used for data processing. Glue is used to build data catalogs and do ETL, but AWS Step Functions is the solution which helps us to like convert workflow into state machine diagram or like visual, so it can be easy to debug. Question number 5, they are telling us you have been given access to streaming data from a game application. Streaming data here. What are the required tools to analyze the stream data effectively and detect anomalies? So they're asking us streaming data, and then how can we analyze the stream data effectively to detect anomalies? So for when we're talking about streaming data, of course, we should think of Kinesis. And for Kinesis, if we look on the options, we have Kinesis Firehose and Kinesis Data Analytics, or Kinesis Firehose and QuickSight. So for streaming data, we can also always think of Kinesis Firehose, but for analyzing the streaming data to detect anomalies, we can use Kinesis Data Analytics, because within Kinesis Data Analytics, we have ML algorithm, which we talked about before. It's called random cat forest, which allows us to detect anomalies in the data. So Kinesis Firehose to stream the data, and Kinesis Data Analytics to analyze the data and detect anomalies. So in this case, option number B is the correct answer. The last question that we're gonna tackle here in this section is as follows. So they are asking us, you are working on a competitor analysis project in a retail company. You are required to stream and ingest the product's data to a data lake. Then you should be able to compare those products to the in-house ones and visualize performance using business intelligence dashboards. Which of the following would be the best and efficient solution? So also, we are required to stream and ingest data. This is the keywords here. Data lake is another keyword. And we should think of visualization this data using BI dashboards. So streaming data, definitely Kinesis. We should think of Kinesis Streams or Kinesis Firehose. Data lake, we definitely should think of S3 in this case. And for doing analysis, we can think of Kinesis Data Analytics. And for visualizing performance, we can think of QuickSight. So this is like without looking into the options, we have like few ideas in mind what could be the right answer. So Kinesis Streams, Kinesis Firehose, Kinesis Data Analytics, S3, and QuickSight. We're looking into options. The first option is Kinesis Firehose, Elasticsearch, Kafka. So Kinesis Data Firehose, it helps us to do data streaming, but neither Elasticsearch or Kafka can help us to do the data lake and to build the BI dashboards. Option number B is telling us Kinesis Data Analytics, S3, and QuickSight. Analytics can help us to do the analysis, but it doesn't allow us to stream the data. So we are still missing the first part, which are required to stream and ingest the product's data. So option B is wrong. Option number C, Kinesis Data Streams, S3, lake formation, and QuickSight. So they're asking us to stream and ingest the product's data to a data lake. Kinesis Data Streams, it helps us to stream the data, but it doesn't help us to send the data to another destination. So we still need like a solution or a tool which help us to take the data from Kinesis Data Streams to S3. However, if we go for Kinesis Data Firehose, it helps us achieve the purpose of streaming the data, sending the data to another destination, which can be S3. Within S3, we can do the data lake or the lake formation, and we can then push the data to QuickSight and do and develop BI dashboards that help stakeholders to drive insights about the product competitive analysis. So yeah, in this case, we should go for option D as the most correct answer. This takes us to the end of the data engineering section. I hope that you find it useful. As I said earlier, you should take this video as like explanatory video for you to know what are the main topics that you should focus on while studying for your AWS ML certification, and you should read more about each of the topics we talked about. And I hope that the questions that we tackle, it gave you a glimpse or taste of real exam questions that you will tackle while sitting for the exam. The next video, we will talk about exploratory data analysis. We follow the same strategy. We will cover the topics, and we're going to end up with sample questions that are identical for the certification exam questions. Thank you.